The EnergyOne Smart Control allows for on-site or remote control and monitoring of heating and ventilation plant, provided by a simple dashboard. Site displays can be located around the buildings, which might draw the building users into the subject of energy use and conservation. Savings usually exceed 20% with paybacks within 18 months. This dashboard uses the ticker-type displays to show current savings in terms of cash, kilowatt hours and tons of CO2 saved. This panel shows how the EnergyOne Smart Control System can integrate into existing building controls to pick up temperature and control status, should this be required. There are a number of different skins that can be used and subject to real estate portfolio size and complexity. These can be customized to suit a client's requirements. This dashboard is the one we use for most demonstrations, as it holds a number of demo sites and data, which is useful to show off the various control strategies. First of these is the alarm system. This shows a map of the UK split into 3 regions. There is a color-coded escalating alarm system providing for a message to be sent to the first in line of support. This would probably take the form of a text message being sent to a local or on-site engineer. If there was no response within, say, 2 hours, then the next up the command line would be sent a message or email, and this continues until someone has reacted to the alarm. A full audit trail is kept for later analysis to determine if service levels are being adhered to. This window shows a snapshot of the properties and their current alert status. It also shows the plant and control status. It can quickly be seen on the left that all sites are okay, with no alerts running. The boiler plant can be seen to be either hot or cold, and the control system is set either to run enabled or manual or no control if service work is being carried out. If we choose the top selection for Barclays University, we get a thumbnail photo of the site and a quick view of the local temperatures. We can see the current outside temperature and 2 of the internal space temperatures. The green panel here allows us to navigate to various sections of the system. By selecting the plant room, we can now see the main elements of the plant at this site. At a glance, we can see the boiler flow and return temperatures, the same for the chiller, and we can see if the air handling system is operational. By selecting boiler, we can now see in more detail the flow and return, pump selectors, and outside and return temperatures. We can also select the Boiler Control tab to demonstrate the plant rules. It is at this point where the rules are configured for the operation of the heating and cooling plant. At the top, there is a panel for setting the plant time override. This will be an exceptional adjustment, which will revert back to the default setting when the time set for override has expired. This can be set for single or multi-site operation to cope with public holidays, for example, where a site may be turned off or down for just one period. Below this is where the site-specific duty times would be set, and below this is where the plant inhibit rules preside. These assure heating and cooling contention are controlled, this often being the area associated with the most waste within a system, where the heating and cooling run at the same time. Providing a dead zone to inhibit this waste can reduce significant levels of consumption. It is also where frost protection and optimized stop and start parameters would be set. EnergyOne Smart Control also uses a proprietary load compensation algorithm, which was developed over 20 years ago and which has been installed in over 2,000 installations, achieving typical savings of over 20%. This illustration shows the main constituents of the air handling system. The airflow speed of around 2.5 meters per second and the filter pressure show the airflow to be within acceptable limits. The flow temperatures of chilled water and boiler output can be seen, an assessment made to ensure against valve let-by at each matrix. Fan activity is monitored, internal and external temperatures observed, and a free cooling assessment made. This tab takes us to the chiller schematic, where we can see flow and return temperatures and pump status. regular pump switching can be programmed to ensure backup plant is operative when required. This could be thought of as the building heartbeat illustration. The key on the right shows the main traces that are used to diagnose plant activity and to provide housekeeping adjustments. This example shows just how poorly a building can be operating, yet, from the occupier's point of view, all appears to be well. This orange line shows the general building internal temperature. This seems to be quite stable at around 21 degrees Celsius. A good performance. However, this graph shows the plant activity starting at midnight up to the current time. It can be clearly shown that at midnight, the boiler flow and return were slowly dropping, as could be expected from the previous day's activities. However, at around 2 a.m., the boiler came on, possibly as a result of some faulty setting in the main building management system or as a result of a temperature variance setting in the BMS. The flow and return climbed quickly, showing that there was very little, if any, demand. The chiller return reacted to a small return temperature increase, and this resulted in the air handling unit coming on at 4 a.m. So the heating and cooling were both running at the same time, yet the space temperatures remained stable. All this activity and consumption taking place many hours before people arrived at the building. When they did arrive, they found the temperature comfortable, but had no idea how much energy was being consumed to no effect on the space temperatures, a complete waste of resources. EnergyOne Smart Control can maintain data records for years, so historic consumption and trends can be monitored over significant periods. By using the AM&T tab, we can look at how the building performs in a variety of ways. We can use national benchmarks to measure any building's performance. This can also be used to build a league table so that we compare one building against another within the real estate portfolio. With this view, we can compare the national average for a similar building. We can see that the Barclays University is fairly good for electrical consumption, as it shows green, but the gas consumption is above the average. We can also use this data to show the cost per square meter of space or even per person. Again, red means poor performance and green better than average. From this panel, we can also look at the specific CO2, electricity, or gas consumption data. This graph shows us the current week's generation. The orange line shows the annual trend. And if we select the Today tab, we can see the amount of CO2 generated in 30-minute intervals. Most monitoring systems can only show this data in what's called day plus one, meaning whatever is generated on a Monday can only be seen the following day. In a similar way, this tab shows the same granularity for electricity, along with its annual rolling comparison. By tabbing down to hourly consumption, we can look in almost real time and spot any irregularities that would show up if plant was running outside of the existing rules. This would then suggest that we take a closer look at the analysis graphs for corrective action. There are many reports available, and these can be configured to suit clients. One of the areas for consideration should be to compare energy consumption before and after installation of plant adjustments. Simple comparison is easy. Caution is required when comparing raw data, as this can be significantly affected by weather changes. EnergyOne Smart Control can provide raw or degree-day adjusted data. Because this is a demo site only, the data flows across each day are the same. In a live system, a degree-day data set will automatically adjust each day's consumption level for accurate comparison. The running total at the bottom of the report can be used for any period of assessment. This report shows each day's consumption graphs, which can be assessed to spot any daily irregularities. Many authorities now demand reports on carbon generation. EnergyOne Smart Control can provide data output in compliance with these demands. Because Smart Control holds huge amounts of data to drive the monitoring and control elements, Almost any client requests can be met when setting up the report generation feeds. If you have any special requests, please ask our engineers for advice. EnergyOne Smart Control is a two-way communication system and as such can be software updated remotely. This facility provides for future-proofing your system, often without the need for our engineers to visit unless further plant is required.